Here are two Bitcoin addresses. On the left, a legacy address starting with 1. On the right, a modern address starting with bc1. Bitcoin redesigned its address format from scratch in 2017. And for some of these new addresses, deleting a single letter still produces a valid-looking result. The answer involves a 1950s error-correcting code and one hexadecimal constant. Segwit activated in 2017. Segwit, short for segregated witness, moves signature data into a separate part of the transaction and introduced new output scripts. Wallets had to upgrade their code anyway to support these scripts, so developers seized the moment to redesign addresses from the ground up. The old format, called base58check, had worked for years but carried 4 real problems. Mixed case made addresses hard to read aloud and ambiguous in handwriting. Error detection existed but could not locate mistakes. QR codes were inefficient and the format had no clean upgrade path for future script types. Bech32 solves all 4 problems. It uses a single case, lowercase, which eliminates handwriting ambiguity and lets QR codes use their more compact uppercase-only mode. Its error detection is built on BCH codes, a family of error-correcting codes from 1950s coding theory researchers Bose-Chaudhuri-Hocquenghem. BCH codes mathematically guarantee detection of small errors and can pinpoint where the error occurred. The name Bech32 itself combines BCH with 32, the size of its character alphabet. Finally, Bech32 bakes in a forward compatibility mechanism called witness versions. New script types can be added later without wallets needing full rewrites. Bech32 looked nearly perfect. It had one flaw. Let's dissect a real address. Take bc1p9h5ha, then some data, ending in 6 checksum characters. The first part, BC, is the human-readable prefix, or HRP. It identifies the network. BC means mainnet. TB means testnet. Next comes the digit 1, a separator. The designers chose 1 over a colon because double-click selection breaks at colons, and they avoided the letter L because it looks like the digit 1. The digit 1 works because it never appears inside the data section. Then comes a single character witness version. The letter Q encodes version 0. The letter P encodes version 1, which is taproot. The middle section is the witness program. And the final 6 characters are the BCH checksum. Now the flaw. BCH codes guarantee error detection only when the code word length stays constant. Bech32's checksum was built with one unlucky constant, the value 1. That choice meant inserting or removing certain characters could preserve validity. Specifically, if an address ends in P, inserting Q characters just before that trailing P often produced a new address whose checksum still verified. For Segwit version 0, this bug was inert in practice. Valid addresses had to be exactly 42 or 62 characters, so an attacker needed to inject exactly 20 Qs. The bug never affected real Bitcoin, but future witness versions were allowed flexible lengths. Under those rules, the same trick could silently create false valid addresses. Imagine sending funds to an address that the wallet accepted but that nobody controls. That risk was unacceptable for a format meant to last decades. The fix is elegant. Bech32m changes exactly 1 number. The final checksum step XORs the polynomial residue against the constant. Bech32 used the value 1. Bech32m uses the value 0 to BCCTO83. The single swap restores the mathematical guarantee any mutation of up to 5 inserted or deleted characters is detected with probability better than 1 in a billion. To avoid confusion between the 2 formats, the witness version character tells the wallet which checksum to verify. Version 0 addresses, those starting with Q after the separator, use Bech32. Version 1 and above, starting with P or later letters, use Bech32m. 2 checksums, 1 address scheme. Now let's look inside the middle section, the witness program. 3 output types dominate today, each built differently. For pay-to-witness public key hash, P2WPKH, you take a public key, hash it with SHA-256, then hash that with RIPE-MD160. The result is a 20-byte program. The address starts with bc1q. For pay-to-witness script hash, P2WSH, you take a full script and hash it once with SHA-256. That gives a 32-byte program. No double hash here. Applying RIPE-MD160 on top of SHA-256 is not always secure against collisions in this context. The address also starts with bc1q. For pay-to-taproot, P2TR, the witness program is a 32-byte SCTP56K1 curve point. The x-coordinate of a public key that commits to additional script parts. The address starts with bc1p. There's a subtle encoding gotcha when these addresses compile to Bitcoin script. The witness version becomes an opcode at the start of the locking script. An opcode is a single byte instruction. Witness version 0 compiles to OP0, which is the byte 0x00 that matches the version number directly. But witness versions 1 through 16 compile to OP1 through OP16, which are the bytes 051 through 060, not 0x01 through 0x10. So version 1 is byte 051. Version 2 is 052. This jump from 000 to 051 is a common source of implementation bugs. A wallet that naively writes the version number as the byte will produce invalid scripts for every address except version 0. Two quick corrections to common misconceptions. First, Bech32m does not replace Bech32 entirely. Bech32 still encodes Segwit version 0, which includes most addresses in circulation today. Bech32m encodes version 1 and above, starting with taproot. The witness version character in the address tells your wallet which checksum algorithm to run. Second, although BCH codes technically can correct small errors, Bitcoin wallets must never autocorrect. A corrected address might be a valid address owned by someone else. Sending funds there is irreversible, so the checksum is used strictly to detect errors and reject bad input. The user must fix typos themselves. These rules, both of them, are spelled out explicitly in BIP350, the Bech32m specification. Compliant wallets follow the official test vectors to catch edge cases. Step back and see the full design. Bech32m is the first Bitcoin address format that expects the future. A wallet written today using the Bech32m checksum and respecting the witness version byte can already send funds to witness versions that do not yet exist. Now, when a new output type activates, the address format requires no change. The witness version character slides from P to Z and onward. The checksum still verifies. The script still passes. The only ecosystem-wide upgrade needed is on the receiving side. Build on Bech32m, use the official test vectors, treat the witness version as opaque, and your wallet stays usable as Bitcoin evolves. Every BC1P you see today is a small promise. The next version of Bitcoin will not make your wallet obsolete.